Hello and welcome to another member sponsor video. In this video we are continuing on with a mini series of putting together a very quick Pong game inside of Python. So in the last video we got Python and PyGames set up and we verified that everything was working well. In this video, Logan, what do you have planned?
Well, we're going to kick off the Pong game itself. Again, the application we made in the last video was just to verify the installation of PyGame.
Okay.
Here in this video, we're going to kick off the Pong game itself. And in this video, I'm going to lay down the framework behind the game. I'm going to set up some variables that will represent the game settings and make a very basic, well, still relatively basic game loop that's going to drive everything. No actual Pong-related code is going in yet except the variables. I'm just laying down some framework.
Getting some structure into place. Okay.
Now, I will note the way I'm going to go about doing this is more of what I would consider a prototype direction. I had very short notice to put this game together, so I am going to be making use of things like global variables. I'll have functions just laying out at the global level, but I am also going to delve into classes. So, I mean, I would almost consider it a hybrid system because I like working with vectors when doing a lot of game calculations and movement calculations. So I'm going to write a vector2 class.
Okay.
Not a complete implementation of one, but a short one that does in fact work.
Enough functionality that gives you what you need.
Right. Also, the game objects that you'll see on the screen will be represented by classes.
Okay.
But then when it comes down to get to the brass tacks of things, we're going to just use a simple while loop at just linearly executed inside of the main file.
Okay.
So again,
once again, just a proof of concept, if you will. Because
right,
yeah, you had very little time to put this together.
Exactly. So it's kind of a combination. I had some nice things going on with an actor and a vector class. I threw some methods down to kind of separate some of the functionality, and then at the end of the day, it all just came down to a loop.
Okay. So where do we begin?
Well, let's begin with a folder to house this game inside of, because I want to have some images go along with it. So I'm here in my C Python projects folder that I created before the last video, but any folder will do. Inside of this folder, I'm going to make a new folder. I'm going to make a Pong folder. And the reason I want to have a separate folder is I want to have a nice container for both the game's script and the images I'm going to use with the game. So in those images, I've got in another folder, I have this ball and paddle. Again, ball is simply a small sideways X character, and the paddle is just a rectangle with rounded edges. Very simple graphics. I'm going to copy both of those files and paste them into my Pong folder for this game. Now, to obtain the script, I'm simply going to make a new text file, and I'm going to call this text file pong.py. And now that I have this created, let me first close it. I had an old copy of the shell running from the last video. Let me get that closed out so I have a nice fresh slate to run from. And with everything closed out, I'm going to right-click on this Pong file and say Edit with idle. So we load up the idle Python IDE, and we'll do all of our coding from within here. All right, now to get things kicked off with the Pong game, I'm going to begin just like the last video and import the PyGame module. And I'm going to import, once again, the whole module. I know, of course, if you want to pick out the specific things and make everything as efficient as possible, you can, of course, do that. Here I'm going to leave everything out because we're going to call this a prototype, so I want to leave a palette of everything open to me as I work on this. Now, I'm going to jot down or place some variables that I'm going to call the game settings. This is going to include things like resolution, a few colors that the game will use, and then a bunch of game-specific variables. So, as a matter of fact, I'm actually going to drop down a comment to say just that. These will be our game settings. First of those is going to be the screen dimensions, or width and height. So I'll do screen underscore width equals 640. We'll do a screen underscore height equal to 480. And we'll use those when we do things like initialize the display and when we calculate the edges of the screen for collisions. All right, moving on from that, I'm going to store two colors in a variable just to make it easier to identify what those are when looking at the code. So I'll make a variable called color underscore black for the color black, which I'll set to a set, because if you remember from the PyGame test video, we had to specify 3 numbers in a sequence in order for the screen fill method or function to work. So I'm going to specify that sequence here as 0, 0, 0. Note that I don't have to enclose these in parentheses here because there's nothing else these could be. We're not looking at arguments here, so comma does not mean another argument. Here it means another element in the sequence.
Okay.
After this color, I'm going to make another color called color green. And I'm going to set that to the values of 166 206, 57. So, or excuse me, yeah, 57, but as the actual number, not 75. Again, not pure green, not full 255, but just a color green that is going to be a light greenish yellow. Okay. But it is the green used by this game, so it's convenient to have it represented here instead of just numbers out in code. Moving on from these, we can look at some of the properties of the game itself. I'm going to start out with a variable called text padding, and this is going to control how far away the scores of each player are going to be drawn off the edges of the screen. And I'm going to set that to a value of 25. After that, we have a variable called paddle speed, which is going to control how fast the paddles will move up and down whenever the appropriate input key is hit. And I'm going to set that to a value of 5. After that, we have another variable called paddle offset. And what this is the spacing, how far the paddles will be spaced off the edges of the screen so they don't reside on the actual edge. That way you'll have some space behind the paddles. I'm going to set this to a value of 10. After this, I'm going to drop down a variable called ball speed. And this is going to be the initial speed that the ball gets as it is first sent off from a direction in the middle of the screen. It can, of course, have speed imparted to it, depending on how gameplay goes on. And one final variable I want to drop down is spin percent. And this variable represents how much motion will be imparted to the ball if it hits a moving paddle. So how much of the paddle's movement gets applied to the ball. And I know the way this works probably differs a little bit from classic Atari-style Pong, but I like the way this works because it gives a nice feel to the control of the game. I'm going to set this to a value of 0.5, representing that the ball will pick up on half of whatever the momentum of the paddle was. And that takes care of what I'm going to term the game settings. We can move on from here, and I'm going to jot down 2 functions. Matter of fact, I'll also jot down a comment. These functions are going to be named update and draw. And I'm separating these into 2 different sections just for readability purposes. In the actual game, they will be called one right after the other. But here it is nice to kind of, in your mind, group things as to, well, what are scene update things to be done and what are drawing things to be done. Now, for the moment, I'm going to simply put down a minimal implementation. I'm just going to drop down the definition of each, and we'll get back to all the specifics later as we have some game objects to work with. So to begin with, we'll define the update method. And update is going to take in an argument. It's going to take in an elapsed time. And inside of this function, I am going to do a return here. And that I'm actually going to be removing this. It's just a temporary return so that we can flesh out the definition here. I'm going to return none just for the time being, just so we can execute the method and have nothing happen.
Okay.
And of course, let me not forget the colon here to make sure we jump inside of this method. After this, I'll define now the other method, the draw method. So def method draw. Draw is going to take in no parameters, but it is going to return none for the time being. And again, the reason I'm doing this is just so that I can run the code and verify that there's no errors.
Right.
Alright, with these functions in place now, I'm going to drop down a comment for a section that I'm going to call initialization. This is where we move into getting everything kicked off, where we'll initialize PyGame and we'll create a screen surface by setting the display mode. So let me also jot this down as a comment. So this will be the initialization section. First thing in initialization is to take PyGame and run the init function. Then after PyGame is initialized, we'll turn around and set the display mode and of course store the surface we get back so we can hang on to that and use it for drawing purposes. And I'm going to use the same variable name I had in the last video, and that was screen. So the screen surface will be equal to pygame.display.set mode, and set mode is going to want the screen width and height. So let's assemble a set out of the variables screen underscore width and screen underscore height. And that has our screen or our display initialized. So that's all I'm going to leave in initialization for the time being. Other things that will be placed here are the creation of game objects, as we need to put them in place, and also set up on those objects. So making sure that they have a texture, making sure that they have a position on the screen. But for the time being, we don't have any objects yet, so initialization will just look at PyGame and screen. All right, the next section I want to set up within this game is what I'm going to call loop control and timing. And this actually comes right before the loop itself, because just like in the example we had done in the last video, I want a variable-controlled loop that can be terminated by changing the value of one variable. And that variable is again going to be game over, which we will start off with the value of false.
Yeah, go ahead and throw the comment in just to keep things looking really
Oh, I completely skipped over it. Yeah, and again, just keeping with our commenting here, we'll mark this section as loop control and timing. Now, what do I mean by timing? Well, I want to set up some code that will facilitate tracking how much time passes every game update. And the reason I want to do this is I want to make sure that the game objects move at a continuous perceived speed, even if the speed of the computer differs, because PyGame will, by default, try to run as fast as possible.
Which is what was going on in the last video when we had the texture bouncing around the screen.
Exactly. I simply made a continuing loop that ran as fast as humanly possible, as fast as the computer was able to draw the frames. And the downside to this is that if we don't watch how much time has passed and simply update the same amount every single update, then a faster computer is going to cause the objects to move faster because it can run that loop faster.
Right.
So what I want to do is I want to track some values that will let me know how much time has passed, and then take that value into consideration when I'm moving something. So basically, move things, if less time has passed, move things by that amount. So that means a faster machine will have less time pass. A lower value multiplied by the amount we move will result in a smaller amount of movement. Okay. Therefore, objects will move slower on a faster machine at a rate which evens out based on how much faster that machine is.
Gotcha.
So we'll put this into place by using two variables. I'm going to make a variable called last tick and another variable called elapsed time. Last tick is just going to keep track of what the current, I'm going to call it timestamp, but really it's the tick value. There is a value inside of PyGame you can read that will give you how many milliseconds have elapsed since the game pygame.init call was run. And that's very useful to us here, because if we remember what that value is and then check it on a subsequent update, we can see, all right, how much time has passed since we last looked at this value and how much its value is right now. Subtract the two, we get a difference, and that tells us how many milliseconds have elapsed since this game loop ran. So we'll have our last tick variable, and I'll go ahead and get that kicked off to the actual value within getTick, so we don't have like one really long looking tick on the very first run. Instead, we have this kicked off to an appropriate value. So I'm going to set this to a value of pygame.time.getTicks. And then I'm going to set up our elapsed time variable. So elapsed time will begin at 0, because this is the beginning of the game, no time has elapsed. Alright, now we are finally ready for the game loop. So I'm going to jot down a game loop comment, and then we can begin the loop itself. And once again, this is going to be a while loop. The loop will continue while not game over. So as long as game over is false, the game will continue to run. So I'll set up the colon, jump into this loop, and once again, the first thing we want to do here inside of our game loop is check any events that have been given since the last game update. And then we'll look through for things like whether or not the game has quit. But to get this set up, I'm going to make an events variable to hold a list of all events that are currently available, and we'll populate that list by running pygame.event.get. So we get all of the events into a list, and then we can loop to that list and look for appropriate events. So we'll set up a for loop of for event in all of the events. We'll do the following. And that is to check the event type and see if it is equal to the value of pygame.quit. If that is indeed the case, that means the user has attempted to exit the game somehow, for example using the close button. So we'll set our game over variable to reflect that. We'll set it to true, making sure that the next time this iteration comes around, we hit the while loop, game over is now true, and we exit the loop. Now, I want to extend this a little bit. In the example when we simply left it as you had to hit the close button, I would also like to set up the loop so that the game can be exited by pressing the escape key. So the individual keys are also given as events. Whenever a key is pressed, that logs an event to PyGame, and we can look for those here. So I could extend this if statement. So we could say else if, or elif, the events type, so otherwise, if the event's type is equal to PyGame.keyDown. And we can continue this on so we can actually do a compound check here. So if the type was keyDown and it was a specific key. So if we know that the event type is a keyDown event, let's look at the key itself. So we'll say event.key and check and see if it is equal to a value of PyGame.k_escape. That's ESCAPE. Okay. So, and this is the case, then once again we would like the game to end, so it's a simple matter of setting our game over variable equal to true. So, a bit of a longer check there, but again, very handy because that's, even without telling the user press escape to exit, that's generally the first thing that you reach for whenever you're trying to close a game. And so that's just a nice convenience matter there.
Okay.
So, let's tab back over now that we're done with the for loop. So we'll tab back and jump out of that for loop. Now let's take a look at our timing system. Let's make sure that we calculate an elapsed time for this current update. So we'll say that the elapsed time is equal to a value of PyGame with a Y, PyGame.time.get ticks. Same call that we used to initialize last tick. But what we're actually looking for here is the difference between what the current tick is and what the last remembered tick was. So the current tick minus the last tick. So that way as time progresses, we always have this running value, this time delta held in elapsed time. So after we get this elapsed time, we need to remember to take last tick and set that equal to whatever the current tick is. So I'm just going to set this equal to whatever the current tick is given by pygame.time.getTicks. Now that we have this value, we know what timing value to feed to the update method. So here what we're going to do is we're going to call the update function. So we'll say update. Of course, update is expecting a parameter, so we'll give that elapsed time. And then immediately after that, we'll make our call to draw. And then that rounds off the while loop. So the code flow here is basically, as we continue looping, things that are checked per iteration of loop are, should we quit the game by looking at the events? Then we update our timing system to make sure that we track a time delta in elapsed time. We use that time to alert update as to how much it should move everything, and then we make a call to draw so that the new state of everything can be drawn to the screen.
Okay.
And let me see. Now that I have all this in place, I'm going to run the game just to test it and make sure that everything works without error, though you'll see no visual result. The only bit of functionality that we'll get is we'll be able to test the escape key against the quit key or quit button and make sure that that they both do the same thing. So I'll do an F5 to save and run, and we get a PyGame window. The shell and the IDE themselves have stopped while we're running this, so that's a good sign. That means our while loop is continuing to run. Mm-hmm. Now if I press the close button, of course the window doesn't uninitialize because we haven't manually called pygame.quit, but you'll notice that we have been given control back inside of the shell, we have been given control back inside of the IDE, so everything has worked. We could run one last time, and this time test with the escape key, and once again, the code exits out, so that does verify that our event checking is working properly.
Excellent.
And with that, I think that's going to wrap up this video.
Okay.
And in the next one, we'll take a look at some more in-depth things with Pong.
All right, sounds good. Thanks a lot, guys.